dear friends, welcome to BYJU'S Exam Prep. I welcome all for this particular NIELIT 2023 series. In this series, we are learning the concepts of data structures. And in this today's session, we discuss the concepts of trees and heaps. Okay? So without wasting much of your time, let us start. Hi, Omigo Tito. Hello, sir. So this is about me. Hopefully you all know about me. If you do not know, this is about me, myself, Sridhar Dhulipala, having 20 plus years of teaching experience, and I am with BYJU'S from past 2 years. Okay? And under BYJU'S Exam Prep app, under the category video lessons, you can find the recorded video content, and I recorded engineering mathematics for all the branches, whereas exclusively for computer science students, C programming, data structures, algorithms, of course, discrete mathematics. You can connect me in my Telegram group, CS_Sridhar. This is my Telegram group where you can get regular updates about my classes on YouTube as well as app, BYJU'S Exam Prep app. Okay, sir? How are you doing? So let us start with the problems. So we'll try to understand the concepts with the problems itself, my dear friends. So here, a binary tree is a rooted tree. It can be either empty, or if it is not empty, it will have a special node called root and two subtrees called left subtree and right subtree, and both left and right subtrees are binary trees, my dear friends. That is, they can be empty, or again they can be binary trees where they have a root and left and right subtrees, which are binary trees. So when you are having a particular binary tree, see here a simple example for a binary tree, sir. This is a simple example of a binary tree. You can call it as a binary tree. So here we call this as depth 0. So root node is at depth 0. The children are at depth 1. Their children are at depth 2. Their children are at depth 3. So the maximum depth possible is what is known as height of the binary tree, my dear friends. So the height of the binary tree is the maximum. Hi sir, good evening, Chandan Kumar. Chandan Kumar, hi. Okay. So already someone answered the question. Very good, sir. What is the height of this particular binary tree, my dear friends? The maximum depth. So my height is 3 in this case. So here, what is that he is asking is, in this particular question, he says that root node is at depth 0. See, because some people take depth as like, root node is at depth 1. So accordingly, the depths varies. But generally, common terminology or common usage is root node is at depth 0. Am I clear? So we follow that. Now here we are having a binary tree. Root node is at depth 0. Root node is at depth 0. And he is asking maximum number of nodes at depth 5. See, here we want maximum number of nodes. Very good, Shyam. Very good, Chandan Kumar. Maximum number of nodes at depth 5. See, if you want maximum number of nodes at depth 5, even the previous depth, we should have maximum nodes. That is, all the levels must be completely filled. And such a binary tree is called, hi sir, such a binary tree is called complete binary tree. Sometimes people call it as full binary tree. The terminology is not fixed, my dear friends. So according to the given terminology and according to the given situation, from the context, we need to fix that terminology, my dear friends. So here if you observe, at depth 0 maximum you can have one node, that is 2 power 0 you can say. At depth 1 maximum you can have two nodes, that is 2 power 1. At depth 2 maximum you can have 4 nodes, that is 2 square. So continuing this way, at depth 5 maximum number of nodes would be what will be the maximum number of nodes? Sanjay Kumar says D Babu. Maximum number of nodes would be what? What is the maximum number of nodes at depth 5? So for depth 5 the maximum number of nodes would be 2 power 5, that is 32. So generally people feel that the concepts are very simple, but they don't need to give any complicated question. Very basic level questions also people generally do mistakes. You can see how many people, yeah, as I mentioned, Omigo Tito, some people may call it as full binary tree, but there is a variation in terminology, sir. Not everyone will use the same terminology, so we need to go from the context also. Context is very important. The next question, height of binary. See, sometimes in GATE examination they'll give you the definitions also, because as I mentioned now, there is a variation in the terminology. So what they do is they'll give you the definition and they'll ask you questions. The height of a binary tree is maximum number of edges in any root to leaf path. In other words, we can say maximum depth is height. Here, what is the minimum number of nodes in a binary tree of height? 10. What is the minimum number of nodes in a binary tree of height? 10. That is the question. So, height is given, you need to find minimum number of nodes. See, for a given height, if you want to get minimum number of nodes, that is possible. The minimum nodes possible. When the minimum nodes possible, sir? When binary tree is, when the binary tree is degenerate binary tree or a skewed binary tree. We generally call this fellow as degenerate binary tree. See, degenerate binary tree means something like this. Skewed left or skewed right or zigzag fellow. Anything you can call it as. So height 10, I cannot show you that. See, if you see height here is 4. For height 4, the nodes, number of nodes, that is I write it as n minimum, which is equal to 5. So similarly for height 10, the minimum number of nodes would be 10 plus 1, which is 11. Very good, Babu. Only few, oh, many people answered. Very good. Nishu answered, Chandan Kumar answered, Sham is answering. See, Omigo Tito, that is what I am trying to tell you, sir. See, full binary tree, some people define like this, strict binary tree. Like, degree of every node is either 0 or 2, they can call it as full binary tree. The terminology varies, my dear friends. So, generally, some people call that as a degree of every node is either 0 or 2, they call it as full binary tree. As I mentioned, some people may call this fellow also as a full binary tree. Even this fellow also can be called as full binary tree. Suppose if you call it as strict binary tree, every strict binary tree need not be complete, but every complete is obviously strict binary tree or full binary tree. In that sense, we can consider that. C is the answer. Very good, sir. All of you doing wonderfully well. Okay. The next question. The height, same definition. I don't want to repeat it. The maximum number of nodes in a binary tree of height h. See, here you want to know the maximum number of nodes in the binary tree of height h. See, you get maximum number of nodes if every depth or every level we have maximum possible nodes. So if I take the same example, at depth 0 we have 2 power 0 nodes, at depth 1 2 power 1 nodes, at depth 2 2 square nodes. So here height is 2. So for height 2, the maximum number of nodes would be what? 2 power 0, 2 power 1, 2 square. Of course, it is a geometric series. Those who attended my classes on this basic fundamentals of discrete mathematics, you know all this formula. So what happens? N maximum, when height, general height is given, you have to go up to 2 power h. 2 square, 2 cube, and so on, 2 power h. And which is given by 2 power h plus 1 minus 1 by 2 minus 1. Yani 2 power h plus 1 minus 1. That is option B. What happened? Why you are sending your photographs, Mona? Please don't send your photographs here. Huh? Okay. Maybe with that, many people may run away. So don't do that. Right. Got it. Next one. The height of a binary tree is maximum number of edges in any route to leaf path. Same story. The difference between maximum and minimum possible number of nodes in a binary tree of height 5. Acha, Mona, you given wrong answer. That's why you are doing that. Don't do that. Okay. Yeah, Nishu Kumar doing wonderfully well. C for Chennai. Yes. So we want difference between maximum number of nodes. We want difference between maximum number of nodes and minimum number of nodes. So just now we done maximum number of nodes is given by 2 power h plus 1 minus 1 and minimum number of nodes is given by h plus 1. So 5 is given now 2 power 6 minus 1 and it is 5 plus 1 yani 6. So 64 minus 1, directly let us write down 63 minus 6 yani 57. C is the correct answer. Wow. Super, perfect, wonderful, nice. Okay. Sometimes some options will be very troubling. The maximum number of leaf nodes in a binary tree having n nodes. What about the maximum leaf nodes possible when number of nodes are given? If I give you number of nodes, for a given number of nodes, the maximum number of nodes will be what? Maximum number of leaf nodes. See, my dear friends, the maximum leaves are possible. The maximum leaves are possible if it is a nearly complete binary tree. If it is a nearly complete binary tree or complete binary tree. So we know for a complete binary tree, okay, the number of nodes is given by 2 power h plus 1 minus 1. This would be the number of nodes for a given height. Now, here the height should be minimum. Height should be minimum because you want maximum number of nodes. That n should be maximum. This h should be minimum. So h minimum value is given by log n plus 1 by 2 to the base 2. Okay. So if this is the value of h, then because at that particular height level only you are going to get leaf nodes. So the number of leaf nodes, the maximum number of leaf nodes will be 2 power h minimum. That is nothing but 2 power log n plus 1 by 2 to the base 2. So these two get cancelled and you are going to get the answer n plus 1 by 2, which is option A. Very good, Babu, Chandan Kumar Babu, Gupta. Wow, wow, wow. Today you people are breaking the chat box. That is different story, Babu. That is the connection between internal nodes and leaf nodes. That is the connection between internal nodes and leaf nodes. Okay. Okay, in that case, how you find that 1 plus, okay, n2 plus 1. N2 plus, but N2 means what? You need to know all the nodes of degree 2. How many are there? How you find that? Now you can do that, because here we assume that every node, of course there may be it is actually maximum, sir. L maximum means what? L maximum means the answer may be floor. You have to take the floor. Huh? Very good, very good. Yeah, we'll come to that also. Agla samasya on your screen. For those who are giving different formulae, unfortunately I come up with those formulae also. So I am also having ilaj for those problems also. Yeah, yeah. See, my dear friends, generally if you are having this many nodes with 0 children, that is leaf nodes you can call them. These are the internal nodes, not necessarily internal, of course internal nodes you can say. Number of nodes of degree 1, that is number of nodes having one child, single child nodes. These are number of nodes having 2 children. So we have a beautiful relation between number of leaf nodes and number of nodes of degree 2 or internal node of degree 2, and that is n2 plus 1. So as someone is mentioning, na, leaf node is equal to internal node of degree 2 plus 1, like that also you can write. You can write that. See, that is only notation. Any way you can write, it does not matter. Any manner you can write, it does not matter. Here he given nodes of degree 10. Here nodes of degree 1 is not important. It is not needed. Not needed. We just need nodes of degree 2. So number of leaf nodes will be number of nodes of degree 2 plus 1, which is 10 plus 1, yani 11. Option B. Option B, my dear friends. So there are some formulae like that. Please practice all the basic formulae from binary trees, my dear friends. So for a given height, what is the minimum number of nodes? What is the maximum number of nodes? What is the minimum leaves and what is the maximum leaves? Similarly, for a given number of nodes, what can be the minimum height? What can be the maximum height? What can be the maximum number of leaf nodes? See, these are all standard results. You should know it. Of course, you can also do it for emery trees, my dear friends. That is what you didn't understand, Babu. What you didn't understand? You didn't understand formula? Are you asking me to derive the formula? Asha Bhatt, Asha Bisht, you want me to derive the formula? Okay, no problem. If you can say something, then I can tell you, sir, what you not understood. Are you expecting the formula derivation? If you are expecting formula derivation, it goes like this. Number of edges would be number of nodes minus 1, because, sorry, number of nodes are number of nodes of degree 0 plus number of nodes of degree 1 plus number of nodes of degree 2 minus 1. Okay, this is number of nodes. Number of nodes minus 1 will be number of edges. But in this particular tree or in a binary tree, how many nodes of degree 0 are there? N0. And these nodes of degree 0 will contribute 0 edges. So if you count with them, there will be 0 edges. If you count number of nodes of degree 1, each node of degree 1 will contribute 1 edge. So that is 1 into n1. Each node of degree 2 will contribute 2 edges. So the number of edges would be 2 into n2. So from this you can get like n0 plus n1 plus n2 minus 1 is equal to, if you simplify, it is n1 plus 2n2. So here n1 cancels. That's why we don't need any n1 relation or n1 information for this particular problem. And you can find n0 is equal to 2n2 minus n2 is nothing but n2 plus 1. And that is the story. Very good evening, Poonam Chandra. How are you doing? See, if you maximum number of height. Okay, that is the answer. Okay, sir, I don't know what you are asking. 1 second, let me just take one empty slide for you. Yeah. Okay. Nana Asha Bhatt, Asha Bist. See here. See, in binary tree, you should learn the following results properly. In a binary tree, the standard results we call them. We should know them. For example, for a given height, we should know minimum number of nodes and maximum number of nodes. For a given height, minimum number of nodes would be h plus 1. Maximum number of nodes would be 2 power h plus 1 minus 1. And you also know, just now we derived it, maximum. What about the maximum number of leaf nodes? For a given height, what about the maximum number of leaf nodes also we can know? That is 2 power h. That is 2 power h. Am I clear? Whereas for a given number of nodes, we can find minimum height. The minimum height for a given number of nodes is given by log n plus 1 by 2 to the base 2. See, actually from this relation you can get this particular result, sir. From this relation you can get this particular relation. Whereas maximum height for a given number of nodes, the maximum height is given by n minus 1. And for a given number of nodes, maximum number of leaf nodes is given by n plus 1 by 2, where n is total number of nodes. Yeah, this also can be written like, log n plus 1 to the base 2 minus log 2. Log 2 to the base 2 would be 1. Like that also you can write it. So these are the standard result which I was talking about. Nana, Asha Bist, clear? Hey, where are you? Sleeping? Yeah. So whenever you ask a question, just ask and don't see other videos. It is YouTube. There will be so many other videos which are going on parallelly, side by side. So YouTube will offer you so many recommended videos based on your interest. So I think your interest might have changed suddenly. Yeah. So if you ask, you have to wait for that. Okay. Otherwise, what happen? You may be moving to suggested videos of YouTube. See, that's why, I generally mention students, see, with YouTube, keeping that discipline or that sincerity and that regular effort is very, very difficult. Okay. If you are able to do with YouTube sessions only, that is wonderful. But you have to put the effort, my dear friends. Am I clear? You have to put your effort. Maybe she not get the answer immediately. She typed maximum height of a binary tree. Another YouTube session happens. So move to that particular video. So this is what happens, my dear friend. Things will not be continuous. See, if at all you are serious, okay, if at all you are serious, you are able to follow any sessions anywhere, not necessarily my sessions, any sessions anywhere. Take a serious, okay, classes and continue. Am I clear? See, if you are very, very serious, there are so many YouTube videos which are already available in the market. Okay, you can do that. This is a problem practice session for a particular examination. This is a problem practice session for a particular examination. So I may not able to derive entire story. See, completing the entire syllabus on YouTube is, okay, obviously from BYJU'S Exam Prep, we may do the support, but don't expect the complete story, my dear friends. But you can get good practice, good number of questions I'll be doing regularly, that's it. Okay, very good. Let us move on to the next story, tree traversal. The tree traversal, that is the order in which you can visit the vertices or the nodes of a tree. The order in which you visit the nodes of a tree, my dear friends. See, if it is a linked list or array, the order is very simple, straightforward. If it is a singly linked list, you start from the head node or the first node, traverse. If it is a doubly linked list, luckily you can traverse back also. Circular linked list, you can make a circular rotation, my dear friends. But tree traversal, it is not like that. Because if you start here, you may move this direction, you may move that direction. So we need to understand what is the order in which we visit the vertices. And for that, we have the following standard tree traversals. That is, tree traversal means standard order of visiting the nodes of a binary tree, my dear friends. The standard order would be pre-order. So here I will be using L for left subtree, R for right subtree, and N for root node. N for root node. In pre-order, first we visit the root node, then left subtree recursively, then right subtree recursively. And when it is post order, in post order, first left subtree, right subtree, then root. And when it is in order traversal, in the in order traversal, the root node is visited between left and right subtrees. So that is the tree traversal, my dear friends. And we have a small technique for this, which you can use for finding traversal of a tree. We start a walk from here. See here, what you can do is you can create some dummy links. That is, whenever there should be a, actually binary tree can have two links. Okay. For leaf nodes, the two links are missing. So we can call them as null links. So I am writing for each null link, I am just putting some dummy link, my dear friends. I am keeping some dummy link for each null node or each leaf node. And if it is a node with single child, there will be one null link, my dear friends, like that. So now we start this traversal. We start this traversal, my dear friends, from here. Yeah, level order, we read level by level, my dear friends. We can have, these are the standard one. Level order is also one more thing where we traverse level by level, my dear friends. Yes, Deepak Gupta. So here what happens, you start from here. Every node you reach, or you, in this particular traversal, every node is visited 3 times. On the left, on the middle, on the right. Okay. So I just start traversing, sir. Just start traversing like this. So you see every node I visit 3 times, on the left, middle, on the right. See, this is already visited on the left, now middle, right will come later. Then this node, left, middle, right. This is right. See, left is done, middle is done, now it is right. So in the traversal, automatically you will visit every node 3 times. Automatically you visit every node 3 times. Middle, this is left, left, middle, right, middle, right, right, middle, left, left, middle, right. Somewhere, oh, it's gone too much. So every node we visit 3 times here. So this is the walk, you can call it. So while walking, you visit every node 3 times. So once you visited on the left, once you visited on the right, and once you visited on the middle. So whenever you visit or whenever you connect that particular node on the left, you call it as 1, middle is 2, right is 3. 1, 2, 3. Left is 1, middle is 2, right is 3. Left is 1, middle is 2, right is 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Again 1, 2, 3. 1, 2, 3. And 1, 2, 3. Yes. Okay. So what happens, if you want any traversal, you can easily get by doing the same walk. So you just do this particular walk from here, sir. You start walking from here. So while walking, whenever you get one, whenever you find one, print the node. Then you get pre-order. So if you print nodes corresponding to ones in the walk, you are going to get the pre-order. So start walking from here. Start walking from here. One you find A, print it. So just walk, and whenever you find the one, you print it. Continue your walk. Again you find one, print it. Continue your walk. See, you are walking. Like this you are walking. You are walking. So whenever you find one, print the node. F. Continue the walk. Again you find one, print the node. Continue. Now 2 3s you can ignore. Then there is a 2, ignore. Move to 1 of K, K is printed. Then continue 2 of K, 3 of K, ignore, 3 of F, ignore, 2 of B, ignore, 1 of G you print it. 1 of L you print it. And 2 of L, 3 of L you ignore, 2 of G, 3 of G you ignore, B3, A2, D1, so print D. Then H1, print H. Then 2H, 3H, D2, I1 you print it. Then continue 2I, 3I, D3, A3, ignore it. So if you print once, you are going to get the pre-order. If you print once while walking, you get the pre-order, my dear friends. It's a very simple story. Hope you all can understand very easily. Similarly, post order. For post order, while walking, you have to print threes. If you print threes, you are going to get the post order. If you print threes, you are going to get the post order. And for in order, you have to print twos. For in order, you have to print twos. Hope you can do that. Do the same walk. While walking, whenever you find 2, the 2 of the node to be printed. That is in order. While walking, whenever you find 3, you print the node. And that will give you the post order. Hope you can try these 2 things, my dear friends. Clear or not? As one of our friend is suggesting, we also have one more order called level order. See, level order is very important for heaps, because complete binary tree satisfying heap property is called heap. Okay. If it is satisfying max heap property, it is a max heap. Satisfying min heap property, it is a min heap. That is it. So here we traverse level by level. First level complete, then second level you complete, then next level you complete F, G, H, I, then last level you complete, that is J, K, L. That is the story. Done. So let us take up the problem. Here, okay, I may be covering the tree, so I just move sideways. Okay. You can see the tree. He is asking what is the post order sequence of this particular tree. What is the post order traversal of this particular tree? You have to give me the post order traversal of this particular tree, my dear friends. Post order traversal. Yeah. Very good. Vision by Chandrakumar says C, so many C's. Deepak Gupta got only 1 C. Omega Tito has only 1 C. Suma Shreya, welcome. Okay, you are attending previous classes regularly. This class today you are late, or you are answering, you just started answering. Very good. C. So most of you might have understood. See, one more way of looking at this particular solution is, when you want post order, the post order. I don't know, I may be covering. Shall I try from here? Shall I try from here? Here also I am covering. Yeah. See, now when you see this particular story, okay. See, it is the root. In a post order, first we complete the left subtree. So first you have to traverse the left subtree in post order. After completing left subtree, then right subtree, then finally root node. So the root node work will be last. Root node will be the last. It is waiting. Mera number aayega last. But first you have to complete left subtree in post order. See, in left subtree again, first you have to complete. Even in the left subtree, first you have to complete left subtree in post order. So if you complete left subtree in the post order, what happens here is, again there is a binary tree. First you have to complete left subtree. The first left subtree is G. Then right subtree, there is no right subtree, happy. See, because left is completed, right is not there, then root node. See, after left and right, root node. Now C is printed. Now left subtree is completed. Then you have to do right subtree. Right subtree single node, happily print it. Now left is completed, right is completed, print the root node. So you completed the left subtree. Now you have to complete the right subtree in post order. Again for right subtree, first left subtree, that is F. Then right subtree, it is not there. Then root node, that is E. Now left is done, right is done. Now A. As I told you now, A is okay. We don't need that much space. A moves little further. Like so, by directly looking at the tree also, we can answer this, my dear friends. Even without writing anything also, you can answer, my dear friends. That if you can develop, you can do wonders. If you can do that, you can do wonders, my dear friends. Even pre-order also can be done in the same manner. Post order, pre-order, in order also can be done in same order. Wonderful. अगला समस्या आपके स्क्रीन पर देखिए, हम अभी दूसरा प्रॉब्लम और अगला प्रॉब्लम सॉल्व करेंगे. ओके, और इसमें इन ऑर्डर और प्री ऑर्डर दिया हुआ है, यानी आपको इन ऑर्डर दिया हुआ है, प्री ऑर्डर भी दिया हुआ है, और आपको पोस्ट ऑर्डर ट्रैवर्सल करना है. So let me write down the in order and pre order separately. We have in order, which is DBEAF, DBEAFCG, and we have pre order. प्री ऑर्डर क्या है इसका? ABD ECFG. ये था समाचार. अभी इस समाचार का एनालिसिस करेंगे, यानी फ्रॉम दिस प्री ऑर्डर इन ऑर्डर आपको पहले पोस्ट ऑर्डर बताना है. यू हैव टू टेल द पोस्ट ऑर्डर. So thing is, you can construct the binary tree when pre-order and in-order are given, post-order, in-order are given, level order, in-order also we can construct a binary tree, my dear friends. But pre-order, post-order we cannot construct binary tree. Of course, if pre-order, post-order are given, and if it is a strict binary tree, that is if it is having either 0 children or 2 children, then we can construct binary tree. Otherwise, no. That is the story. Wow, Deepak Gupta, today you are rocking, man. Super. Wonderful. So, Deepak Gupta already solved the problem. So, he given a challenge to us to solve the problem quickly. But we will take it, okay, in a positive manner. We will try to understand and solve it. So, first what you do is you see the pre-order. Pre-order. The first, in the pre-order, first root node, then the left subtree, then the right subtree. So, first element is the root. So, from pre-order, you identify the root node. Nishu also doing well. Shreya, very good. Shreya given option A. Let us see. Okay, very good. So, once you see the root node, you try to go back to the in order. See, if you see in order always left root right. That is, the root node separates your left subtree and right subtree. So you can easily understand. These are the nodes in your left subtree and these are the nodes in your right subtree. D, B, E are nodes in the left subtree and F, C, G are nodes in the right subtree. And this is in order, sir. Whatever I written here, it is in order, my dear friends. And if you observe, the three nodes will give you the pre-order. Three elements, na? I think DBE, it is BDE. Pre-order for the same is BDE. And pre-order for the remaining three fellows. Okay. See, you can see how many elements are there in the left subtree? 3. So the first 3 will be pre-order of left subtree. The next 3 will be pre-order of right subtree. So now you have pre-order of right subtree also. Now what we need to do is, you try to identify the root node for the left subtree. Root node is B. So root node will separate left and right subtree. Clearly you got the answer. Now here root node is C. So that is this fellow. So it is happy situation A. So now B is the root, means this has to be left subtree, this has to be right subtree. C is the root node, means this is left subtree and this is right subtree. So if you want, what is that he want? He want the post order. The post order would be, what is the post order, sir? Left right root. Yani D, E, B, F, G, C, A. So that is your answer, my friends. D, E, B, F, G, C, A. That is option A. Super. So this type of problems are very regular in GATE also. So in NIELIT kind of examination, they are very important. This type of problems are very important for exams, competitive exams like NIELIT, ISRO, etc. BARC also. Now the post order and in order are given. He is asking height. Post order and in order are given and he is asking what is the height. Same story. Post order. 896 745 231. In order 869 472 513. हाँ बस कर लेंगे ऐसे ही. Okay. So do it na. Just you can answer faster na. You should have done it faster. Okay. First you got this. Oh sorry, it is a post order na. Post order means the last node would be the root node. In the post order, the last node is root node. Am I clear? So this is the root node. And you see root node is this fellow. This will separate your left subtree and right subtree. So left subtree in order we know, that is 8, 6, 9, 4, 7, 2, 5. Right subtree single element, it is done. So here also you can see post order of the left subtree and this is right subtree. So again in this the root node is 2 and 2 will separate what? 2 will separate your left and right subtree. Again it continues 1, 3 and here 2 is the root and 5 is the left subtree. Again you see this 8, 6, 9, 4, 7 is the left subtree. So in order of the left subtree is 8, 6, 9, 4, 7. That is the in order. Then 8, 6, 9, 6, 7, 4 up to here would be the post order. In that the root node is 4 See, every time that root node is separating, last but one node is becoming root node, but don't blindly do that. Suddenly somewhere they may change that story. So it is very simple, 2, 3. Now 4 is the root, 7 is right side, and it is the in order of left subtree. So within that circle I am writing in order. 8, 6, 9, this is your post order. Now luckily 6 is the root, so 6 will separate left and right subtree. So one more level you are going to get, that is height will be, finally the height would be 1, 3, I think this is 5, 2, 5, 4, 7, and it is 6, means here it is 9 and here it is 8. So the height of this particular tree is 4, my dear friends, and that is what he is asking. Height is 4. Dear, oi, Shreya, what happened, sir? Suma, 6, sir. How? Guessed, It's not that, na. Height is 1, 2, 3, 4. B is the answer. अगला समस्या आपके स्क्रीन पर. Quickly answer this. Oh, Manishankar Tiwari also here. Yeah, some people are coming regularly, but suddenly in between. The nodes of a binary tree are labeled by capital letters. The in-order traversal of the tree is given and the pre-order traversal is given. So he is asking how many nodes are there in the left subtree. So people are answering C, they are saying. Very good, sir. See, here you don't have to solve the entire problem. Pre-order, you know the root, and you see the root is here. So how many nodes are there in the left subtree? You just count this. 1, 2, 3, 4, 5, 6 is the answer. You just need to tell how many nodes are there in the left subtree. So just root node is this. So in the left subtree, these are the nodes. A, B, C, D, E, F. Remaining fellows will be in the right subtree. He is just asking how many nodes are there in the left subtree. That is the answer. Super. The next problem, binary search tree. See, in binary search tree, what happens, sir? The root node value is larger than all the keys in the left subtree and is smaller than all the keys in the right subtree. And the same continues for its children, their children, and their children. That is, every node is larger than its left child and smaller than its right child. And you can do that recursively so that the entire story can be easily understood. Okay, that is about binary search tree. The key of the node or root node is larger than all the keys in the left subtree, and the key value of the root node is smaller than all the keys in the right subtree, and both the left and right subtrees are binary search trees in their own right. That is the story. What is the answer here? So we have, okay, sorry, somewhere it's gone. Okay, this 43 we are trying to locate. You have to find the probe sequence, my dear friends. You have to find the probe sequence. 43 you are finding. So people are saying B is the answer. You have to tell which one is the correct probe sequence. See, my dear friends, if you start One method they use is they construct the binary search tree, and if it becomes a degenerate binary tree till you reach 43, then that is correct probe sequence. Suppose if it is having different what do you call, from a node, if you are getting two separate edges, okay, then what happens, that is not a proper probe sequence. That idea you can use it. So start inserting these fellows. 3 is larger, 50 is larger. See, you can get a degenerate tree or you can get that zigzag binary tree, my dear friends. The simple thing is each node should have single child. Each node should have single child in that process. 40 is less than 50. 60 is greater than 50, and you see this one, it is not a degenerate one, so this is not the correct answer. 43 is not the correct answer. Next one, that is 43 is not the correct probe sequence. See, for finding or for searching 43, this is not the correct probe sequence. Next, option B, BCD correct option. Next, B, 10, 65 greater than this, then 31 is greater than 10 and less than 65, then 48 is greater than 10, less than 65, greater than 31, then 37 is greater, less, greater, less, then 43 greater, less, greater, less, and greater. It is possible. B is the correct answer. So next one is C option, 81. Next is 61 less than that. Next is 52 less than that. Next is 14 less than that. Next is 41. 41 means what happens, sir? It is less than, but it is greater than this. Next is 43. Yes, this is also possible. No? C is also possible. It is MSQ question, sir. He is asking which of the following are possible. So it is MSQ, obviously. I forgot to mention MSQ. It is MSQ. Of course, for so they can ask you which one is not possible. So if you want to make it MCQ, you can say which one is not possible. Then it is MCQ. If you say not, then it becomes MCQ. Then option is A is the correct answer. Okay, because NIELIT we don't have MSQs, so that is the answer. Very good, very good. Next one. The following numbers are inserted into empty binary search tree in the given order. What is the height of binary search tree? Just keep on inserting these nodes and you have to tell the height of the binary tree. 2 Acha, for MCQ previous one, 2 A is the answer, correct. Thank you, Nishu. This is data structures. So what about data structures? 10 less than 10 greater than 1, 5 less than 10 greater than 1 greater than 3, 15 greater than 10, 12 greater than 10 but less than 15, 16 greater than 15. So the height would be 3, my dear friends. B is the correct answer. Next we move on to heaps. Let us move on to heaps, my dear friends. Actually, if you observe in the data structures, the main part is trees. The binary trees is the most important. Even if you are preparing for GATE point of view, mostly you can see most number of questions from binary trees, binary heaps, then followed by stack. Stack is also very important. then comes queues, linked list, find queues, then arrays. Of course, arrays, the questions mostly they'll ask you from C programming. Trees, hard. If you don't know trees, you better not to go for examination only. Take rest. Okay, at least you can improve your glamour by sleeping. That is better idea. Right? So you have to say, you have to tell me which of the following is binary max heap. See, the logic is very simple, sir. Of course, from the array itself you can say. See, array indices 1, 2 like that. You can always check like this, sir. You start from here. This is the left node and this is the right node. So max heap means this 25 should be larger than both these fellows. 25 should be larger than both these fellows. Satisfied. Next 12, you start with the next two nodes, 13 and 10. 12 should be larger than both, but it is failed. 12 is not larger than 13, you stop there. Therefore, it is not a max heap. Therefore, it is not a max heap. See, any node should be larger than its both left and right child. And here we can easily identify what is the left child and what is the right child by difference. Next one, option B. You start from here. This is the left child, this is the right child. Just see the next two fellows are left and right child for first node. Obviously 25 is larger than both the fellows. Happy situation. Then 14 you take. See, because up to 13 you already taken, the next two nodes are the children of 14. Left child, right child. But 16 is not smaller than 14. It is failed. It is failed. Then next you see this one. 25 is larger than both 14 and 16. Happy. Then 14 is larger than both 13 and 10. Happy. Then next 14 is done. Next 16. 16 is larger than 8 and 12. So it is correct answer. C is the correct answer. Next one. 25 is larger than 14 and 12. Happy. 14 is larger than 13 and 10. Happy. The next one is 12. 12 is larger than 8 but failed for 16. Failed for 16. You can do that, sir. I always suggest tree only. Today I am little tired, so doing other method. Or you can just do that. You can just do that binary tree. Okay, complete binary tree. 25. See, while drawing only you will understand 25 should be larger than 12 and 16. Done. Then next two. 13 failed. You stop here. It is failed here. You stop here. Using the binary tree is mostly logical approach. This is, of course, logical physical approach. See, there are two ways of constructing heap. One is create an array, convert into heap, and that will take theta n time. Order n time you can complete that. The second method is insert the nodes one after the other into empty heap. That also can construct the heap, but the complexity for that would be n log n. The complexity for that would be n log n. So note that point. Here array is converted to heap. Array is converted to heap. The conversion of array into heap, we have a function called build heap because it is a max heap, na? Max heap. So we call it as build max heap. So this build max heap function, we use it, and the complexity of this fellow is theta n, my dear friends. Complexity of this complexities also can be asked, so please note that. The theta n. Okay. So all of you know this. Very good. Okay. So it's very simple. First construct the binary tree. 89, 19, 40, 17, 12, 10, 2, 5, 7, 11, 6, 9 and 70. See, you start with the node which do not have, you start with the node which is having at least one child. So that is 10. See, what we need to do is, you have to compare 10 with both its children. If any child has the maximum value, then this swap with that. That is, you have to swap the root node with the maximum value or the maximum child key. 70 is larger, so 70 moves up, 10 goes down. Swap this fellow with the larger child. That is the point. Swap this node value with larger child if it is present. So this is called heapify procedure. So a particular node comparing with its children, okay, if at all it is smaller than its children, you have to swap that node with the larger child. Then continue from there also till you reach the leaf level. This process is called heapification or heapify procedure, and the complexity of heapify is order log n. Order log n is the complexity of it. Next, this is done. Next, 12. 12 is larger than both its children, so no need of doing any heapification. Then 17. 17 is also larger than both its children. Done. Then move to 40. 40 is not larger, so swap with the larger child, that is 40 moves down and 70 moves up. Again 40 is compared with its children, there it is fine because it is larger than. Okay. So you need to identify how many interchange we done so far, sir. Here one interchange done, here second interchange is done. So one is done, now two interchanges. So this is done. Now 19 is already larger than its children, no need of doing anything. Then 89 is compared with both its children, it is larger. So only just two interchanges are required to convert this array into max heap. That is, in theta and time you can convert the array into max heap, my dear friends. That is the story. Next, we'll conclude this with the two AVL problems. Hopefully you all know about AVL. AVL, there is one very important result. The minimum number of nodes is given by NH minus 1 plus NH minus 2 plus 1. This is a formula, my dear friends, to find the minimum number of nodes for a given height. To find minimum number of nodes for a given height, my dear friends. And base level, height 0, 1 node, height 1, 2 nodes. So remaining all are, just add the previous two values plus 1. Previous two are, so to know the values, any value, just add the previous two values and add 1. That is, previous two values is 2 plus 1 plus 1, that is 4. Previous two values means 4 plus 2, 6 plus 1, that is 7. Previous two, 7 plus 4, 11 plus 1, 12. Previous two, 12 plus 7, 19 plus 1, 20. And 20 plus 12, 32 plus 1, that is 33. So the answer for this is 33. Okay. So this is the minimum number of nodes problem. Very important for GATE point of view, even for such examination also. Okay, sir. Here he is asking you to insert into an initially empty AVL tree. Okay, using insertion algorithm, rebalancing. Then after drawing that particular tree, you have to tell the pre-order for that particular resulting tree. You have to give the pre-order for the resulting tree, my dear friends. So first of all, in AVL tree, as long as there is no violation, it is same as insertion into BST only. Okay, so we start inserting. First 4, if you insert, no problem. Then you insert 3, no problem, because balance factor violation is not there. Then when you insert 2, there is a balance violation. There is a balance violation happened here. This is 2 minus right subtree height is 0, left subtree height is 2, starting from here. So what happens? 2 minus 0 is 2, because there is a balance factor violation happened, and this is due to left of left somewhere you done insertion. Therefore you simply do the LL rotation, my dear friends. LL rotation is just 3 moves up, 4 moves to the right. That is just make this rotation. LL rotation is just this rotation. Am I clear? Very good. After that, continue your insertion. 9 you are inserting. 9 is larger than 3, larger than 4, so 9 comes here. Then 6 comes. 6 is larger than 3, larger than 4, but smaller than 9. And here the balance violation happens, minus 2. This is due to right of left somewhere you done the insertion. Right of left somewhere you done the insertion. So it is RL rotation. Directly you can do it, or first do LL followed by RR will give you the answer, or directly you can just make this. See, this will go up, 4 will move left, 9 will move right, and you have to give the pre-order for that, my dear friends. What is the pre-order for this? Pre-order means root left to right. Root is 3, left is 2, then again root to left to right. 3, 2, 6, 4, 9. Deepak Gupta, super. So that is about your data structures, my dear friends, for NIELIT course. Okay. So I revised the important questions which are likely to be asked for this particular examination. And one more interesting thing which you need, or important thing which we need to note, is know the complexities, basic complexities, because they are also useful in algorithms also. Okay, they ask you very general questions, my dear friends. Am I clear? So like, complexities for binary search tree. What is the complexity for binary search tree? Insertion is theta n, deletion is theta n, search is theta n in worst case. But when it is a balanced binary search tree, it becomes theta log n, my dear friends. So these kind of things we should know. Okay, and please do practice them regularly, my dear friends. General question also they can ask you in such examination. Okay. हाँ, algorithm का भी है, algo का भी है. Algo, I think after few sessions, sir. It's not my session immediately, because I am preoccupied with some other classes. Okay, so algo का भी है, maybe after 10 days, after 2-3 sessions, because every week one subject we are doing. So Murli sir as well as Satya sir are taking the other subjects also. Please do attend all the sessions. Okay, they'll be helpful. Am I clear? We are also starting this NIELIT course on BYJU'S Exam Prep app. You can join that particular course for, not just the classes, even the practice questions, tests and everything. Thank you very much, sir. Thank you very much. That's all for today. If you have anything else to ask, you can ask me. Otherwise, I'll call it a day. Now it is open for general discussion, Babu. You can ask anything. Thank you, Chandan Kumar. Chandan Kumar, thank you very much. Usha Ja, next class Monday. I think from Monday onwards, Satya sir is taking the next subject. From Monday onwards, Satya sir is taking the next subject. OOPS concepts, because that is very important for you. I think OOPS concepts he is taking. OOPS, because that is not there for your gate point of view, so those ideas will be very important. Yeah, we completed this subject for YouTube sessions, my dear friends. For YouTube, yeah, generally 7 o'clock this particular session, but because I am occupied with my app classes, so I am not able to take it 7 o'clock. That's why I am taking it 10:15, sir. Algorithm will be done, sir, but not immediately because there are some other sessions happening. After that, my algorithm session will be started. Okay. But here discrete maths we don't have much, sir. Only probability and combinatorics. Rakesh sir is taking the apti part in Saturdays. I think Saturday you are having, tomorrow you are having apti session. Apti sessions every Saturday, I think it is happening. Okay. See, the analysis, this NIELIT or NIC series is happening regularly, sir. Every week we are having. See, electrical subjects hardly how many marks, sir? 4-5 marks. I don't think there are any sessions for that. I'll just inform them if you are interested. See, if more students are interested, definitely why don't they conduct, sir? Right? If you are interested, okay. So keep posting that message in every session. So definitely they'll come up with, because faculty would like to take, okay. Faculty would like to take such sessions on YouTube, definitely, whenever students are interested. See, there are two types of sessions which happens: regular sessions, or if you are interested. See, if no one is interested, now hardly people, uh, their very seriousness is coming down. Am I clear? Maybe in just in the time of lockdown, people watched many videos. Now people are not doing that on regular basis. If you are not interested, obviously things will happen as a formality. Engineering mathematics, I think some sessions are going on by Ankit Joshi sir. Okay. Not much, sir. Engineering, Deepak Gupta for NIC, NLC, I mean NIELIT or NIC examination, we have only probability and combinatorics. Not much. I think earlier they have all that in the syllabus, but now they restricted only to probability and combinatorics. So probability, some sessions are taken by Rakesh sir, and I am taking combinatorics session. That's it. Only that much is there. Yes, probability and combinatorics. Interesting part. Uh, See, for GATE Sumastreya, sessions will be there continuously, because year long some session or the other will be continued, because now fundamental series are happening. In that also there may be some engineering sessions Rakesh Talreja sir is taking. So definitely we plan many sessions, my dear friend, depending on your interest. Definitely I think some engineering mathematics sessions are going on by Ankit Joshi sir. Okay, they're on. You subscribe to the channel, you'll get regular notification. There is something called bell icon. Just you press the bell icon, you will get the regular notification. Okay, na? Okay. Anything else? Someone is asking, like, yeah, someone Usha, someone is asking, right? Usha ja. See, mainly for this NIC or this kind of ISRO or these examinations, they are not tough. If you can know all the standard results, if you can attend all such classes, practice problems, then you know what is the maximum level for such examination. So it is not that difficult as GATE examination, my dear friends. It is possible. If you want support, definitely you can join. BYJU'S Exam Prep is offering the NIELIT course. Am I clear? See, if you ask if it is sufficient, obviously you have to put continuous effort. See, whether you do it on YouTube or whether that is self-study or whether you do by a coaching. In coaching, what happens? Things happen in a systematic manner. Whereas when you are doing it on your own, you have to find the right place, okay, right notes. See, whatever you are doing, prepare your own notes. Your notes is very important. Prepare your notes and practice good number of questions. Get problems if you can practice that 1 mark questions, not difficult ones, basic ones. If you can practice it, it's enough. Thank you, sir. Okay, na? That's all for today, sir. Signing off.